Hello students, welcome to another tutorial on linear motion. In this video, we're going to look at a question I left you guys with in the previous video. It's another application video or another application question. I hope you tried it. Let's quickly go through the question and see what we're being asked to find. The question reads, a paper in the journal Current Biology tells us of some jellyfish-like animals that attack their prey by launching stinging cells in one of the animal kingdom's fastest movements. High-speed photography showed the cells were accelerated from rest for 700 nanoseconds at 5.30 times 10 to the power 7 meters per second squared. A, calculate the maximum speed reached by the cells, and B, the distance traveled during this acceleration. So here, this question is kind of a little bit straightforward. The extra details that they've given us in the first part, it's basically just information to us. It doesn't help us to work out this particular problem. So the first part, probably from here all the way up to here, this doesn't help us to work out the question. The details that actually are part of the solution start from rest and the time that it accelerates through. And then we are also given the acceleration here. And then lastly, they want us to find the maximum speed, what we're looking for, which is the final velocity. So with that in mind, let's quickly look at how we work out this question. Okay, so if we look at what we're given here, starting from high speed, so high-speed photography showed the cells were accelerated from rest, meaning the initial velocity is 0 for 700 nanoseconds. So what we have there is a unit of time. So that is 700 nanoseconds. So here, this question is not examining us on whether we know how to convert 700 nanoseconds to seconds, but of course we need the time to be in seconds. Okay, so of course, 700 nanoseconds is equivalent to 700 times 10 to the power negative 9 seconds. So if you're still struggling with how to convert units, I'll leave a link in the description so that you can check out my video on how to convert units. Okay, so with that, what else are they saying? The acceleration. So it changes, it accelerates from rest for this duration at an acceleration of 5.30 by 10 to the power positive 7 meters per second squared. So that is the acceleration. In the first part, they are asking us to calculate the maximum speed reached by the cells. Maximum speed. So they're asking for the final velocity. How do we do that? Well, this is quite basic. We're going to use the first equation, v is equals to u plus at. Since we're given the time, this equation works well. We're not given the distance, so we've skipped or weighted equation 2, which has distance, and equation 3. So from here, we want to find the final velocity. No need for making this subject the formula since it is already. So v is equals to the initial velocity is 0. So we only have the acceleration, which is 5.30 by 10 to the power 7. And this is multiplying the time. The time is 700 nanoseconds, but we use it in seconds because the speed is in meters per second. Even the time would have to have that unit of the second, that unit of time. So 700 by 10 to the power negative 9 seconds. Okay, so with that in mind, we can then perform the calculation here. We just multiply these two, and if we did, we're going to get the velocity as 37.1 meters per second. Okay, next, in the second part, the question is asking us for one simple thing: the distance traveled during the acceleration. So as this animal was accelerating, how much distance does it actually cover? So here, any equation will work provided it has distance, whether we can use v squared is equals to u squared plus 2as. But here, just in case we made a mistake while calculating this velocity, we're going to use this expression that doesn't require that velocity. So s is equals to half at squared. But of course, you guys can try to use this equation and try to see if we'll find the same value of s using this equation. But for us, we're going to use this equation. So we're trying to find the distance here, so we'll keep it. Distance is equals to the initial velocity is 0, so the first term becomes 0, so we only have half multiplying the acceleration. So again, the acceleration is 5.30 by 10 to the power positive 7. The time, 700 nanoseconds, but again, we'll use it in seconds. So by 10 to the power negative 9, then this is raised to the power 2, because t here is raised to power 2. If we simplify this, we should see that we're going to get 1.2985 by 10 to the power negative 5. This is distance now. I can bring the units per meter. But when you look at everything else that you're given in the question, you notice that we're trying to lean towards us using 3 significant figures. A good example is this 5.30. So because of that, even our value here, we're going to give it to 3 significant figures. So this is going to be 1.2. Now, when we round off there, this won't be 1.2. This becomes 1.30 by 10 to the power negative 5 meters. Okay, so the final value, the final distance is 1.30 by 10 to the power negative 5 meters. Okay, so I hope you guys were able to follow through to something very, very short and quick. Okay, so with that in mind, this is where this video ends. I hope you guys found it helpful. If you did, let me know in the comment section. In the next tutorial, we're going to look at one other interesting question. So you guys can take a look at it in advance. And if there's any question that you want me to look at, you can always get in touch with me. Okay, so this question is coming from an exam paper, so you guys can try it out in advance. So we're going to see exactly how we work out this question. All right, you guys, this was your tutor. We'll see you guys in the next tutorial.